Hi, this is Sean Chua from SimpleCamConcepts.com. Welcome back. Now, in the previous video, we discussed about rate of reactions. Today, I'm going to continue with this very important topic, and I'm going to introduce to you a new concept known as collision theory. Now, in collision theory, there are two criteria that we need to take note of. Alright, the first one is particles must collide. Alright, let's take a look at this first. So let me give you an example using a marker. Let's say a reaction is reactant A plus reactant B give you the product called C. So an analogy is using this marker. So reactant A, reactant B, when they collide, become your product. So this is the product C. Alright, A, B, C. So it's very easy. So if you just follow criteria number 1 of collision theory, they must collide. So reactant A and B must collide. But realize this is not sufficient because even though they collide, they might not have collided with enough energy. So the cap might have dropped. So this is not a product. So collision theory came in and stated that you need to have a second criteria that the reacting particles A and B must collide with sufficient energy, alright, such that it is equal or greater than the activation energy. So activation energy is kind of an obstacle. So let me go back to the analogy to show you. So reactant A and B, they must collide with sufficient energy, right? And then they form product C. Realize the cap will not drop out anymore. Now this is collision theory. So any reacting particles that react this way, we will then say they have an effective collisions. Sometimes we say successful collisions, and reaction will occur. Now, when we link this back to rate of reaction, all right, how fast a chemical reaction occur, there are actually 5 factors we need to consider. All right, these 5 factors, whatever you do to it, when they increase the rate of reaction, it must have increased the frequency of these effective collisions. So these are some of the keywords we are looking for. Okay. So let me show you one at a time. First factor will be your temperature. Alright? Temperature affects any reactions. Alright? Any reaction will be affected by this temperature factor, such that when you increase the temperature, you will then increase the kinetic energy of the reacting particles. So the particles move faster. This obviously will increase the frequency of effective collisions. Alright? And this will cause the rate of reaction to increase. And yes, these are all the keywords they were looking for in an exam. Alright? So this is the first factor, temperature. Now the second factor is known as surface area. And this will only affect your solid reactant. So this will only affect the solid reactant. What happens is, if you have a solid reactant and you will chop it, you cut it into smaller pieces. Alright? So what you do is, if you decrease the particle size of the solid, what you are doing is that you are increasing the surface area. Alright? And this will increase the frequency of your effective collision. Let me show you an example. Alright. Okay. Let's say you have magnesium block or magnesium ribbon, for example. Okay. And this solid reactant, let's say it's measuring 2 cm by 2 cm by 2 cm. Alright. If you calculate the total surface area of this solid, it will then be one surface, the surface area, 2 times 2, that is 4. Multiplied by 6 sides. So you have 6 times 4, 24 cm squared. So this is the total surface area. Let's see what happens when I cut it into equal pieces. So this is a cube. If I cut it into equal pieces, I will have 8 smaller pieces. And you measure 1 cm by 1 cm by 1 cm. Alright, so now if you calculate the total surface area, each surface area is 1 by 1. So 1 times 1, 1 cm squared. 6 sides, that will be 6 cm squared. Alright? And then you have 8 pieces. 6 times 8, you have 48 cm squared. So what you can see is every time I cut the solid reactant in smaller pieces, So the particle size becomes smaller. Surface area actually increases. So in this case, it doubles. Right? This also means that reactants such as your acid, your aqueous reactants, right, will have twice the ability, right, or the speed or the opportunity to react with this magnesium ribbon. Okay, so this obviously increases the frequency of effective collision. So that's surface area. Now the third one I'll discuss about is pressure. Do note that pressure only affects gaseous reactant. Alright? So what happens is pressure means you pressure something. Alright? Let's say you increase the pressure of a container having two reacting particles and they're coming to react. When you increase the pressure, right, so the volume will decrease. So it's as good as saying that the volume will decrease. So the reacting particles are what? They are now more closely packed together. They have higher chance to come together. That also means increase in the frequency of effective collision. And this again increase the rate of reaction. So this is the third factor, pressure, and it applies to gaseous reactants. Alright, reactants that are gases. The fourth one, which I'll talk about, is known as concentration. Concentration, usually we talk about solutions, so like aqueous solution, alright? It can also apply to gases, but for ordinary chemistry level, alright, normally we just use aqueous solutions to discuss. So concentration, I will say that it affects your solutions, alright? Reactants that are solutions. Now, what happens is if you increase the concentrations, let's say a mole per day cube, if you increase the concentration, alright, of a certain reactant, then there will be increase in the number of reacting particles per unit volume. Alright, so this obviously will increase again the frequency of effective collisions and thus increase the rate of reaction. So this is number 4. And we have number 5. This one is when you add in a suitable catalyst. Alright, different chemical reaction will be affected by different catalysts. That's why we always say it must be a suitable catalyst. Right? So this is the 5th one. Now, catalyst, what happens? You need to know the definition. A catalyst is a substance which lowers the activation energy. You still remember that is the obstacle that we need to clear. So it lowers the activation energy of the reaction such that right now you have more particles, alright, that have sufficient energy. Right? More particles would have sufficient energy to collide, to overcome the activation energy, and this will increase the frequency of effective collision, thus increasing the rate of reaction. Alright, so once again, the summary, collision theory, alright, how do we get effective collisions and why is it important to consider effective collisions when it comes to rate of reaction. And this ties nicely with the 5 factors that will increase or decrease the rate of reaction. Temperature will affect any reaction. Surface area only affects solid reactant. Pressure only affects gaseous reactant. Concentration affect reactant that are in aqueous solutions. Last but not least, by adding a suitable catalyst, we will also increase the rate of reaction. Alright, before we go, let me give you a question itself. Let me find a space here. Now, let's say I have this example. Alright, magnesium plus hydrochloric acid gives you salt solution, magnesium chloride, and hydrogen gas. Alright, take a look at the example, acid metal reaction. Can you now take a look at the 5 factors and decide which of these 5 factors will increase or decrease the rate of this reaction if I have the opportunity to change them in the school laboratory. I hope you learned something useful today. Feel free to come back to look at more videos as well as to share these videos with your friends. I look forward to seeing you in the next video. Thank you.